Hello, welcome to this part. In the previous video, we have designed two GPIO on the PL part and we have generated a bit file. Now in this part, I'm going to verify either my designed system is working or not. So go to the file. First step is export hardware. Include bitstream. Click OK. Again, launch SDK. So SDK is being launched. In that part, again we will verify our system. We will receive inputs from switches and send these inputs to the LED LEDs, and LEDs will blink on and off accordingly. Okay, SDK is opened. You can see a system hardware file. This one is system hardware file. So it has AXI GPIO 0 and AXI GPIO 1, and these are the addresses. If you will see these addresses, I have shown you these addresses in the previous video, and we are going to use these addresses now here in this video. So the first step is go to the file, application project, GPIO testing. You can write any name, standalone system. So Zybo has two processors. One is Cortex 9.0 and other one is Cortex 9.1. By default, one is inactive, so we are going to use 0. Click here, see, next. So click on the switch, click on the hello, finish. Okay, we have GPIO testing here. Click here, click include, two. Okay, yeah, sorry. It is taking time. Okay, it is open now. Click here, go down to the hello. So that is the file in which I will write some code in order to test that either our system is working correctly or not. So here we need to connect Zybo board with the PC. I'm connecting Zybo with the PC. If you have, please connect it, because from now you cannot work without Zybo board. or whatever board you have. The first step is to download the bit file into the FPGA, into the Zybo, into the PL part of the Zybo. Click here. If you will see, we have a bit file, and that bit file will be downloaded into the Zybo board by clicking program. Okay, it is done. The next step is to do some setting. Click on the terminal, setting, serial, COM port, and that one is the baud rate for the by default baud rate. Here we need, first of all, we need to check either my connected system is working perfectly or not. So go to the GPIO testing, right click here and launch on hardware. Go to the terminal. Okay, if you will see a hello world, it means that your Zybo board is working perfectly. Now the next step is to write some code in order to take inputs from the switches and show these input on the LED which are present on the Zybo board. Okay, I will copy some code here, because if I will write the whole code here it will take some time, and after copying the whole code here I will teach you how this code is working. I will explain every line. Okay, I have copied some code here. I will explain line by line. First of all, you have to include two files. This file is very important, because it contains all the things which are being used by the processor system, and this is the header file of XGPIO. So you have to include these two files. Okay, the next step, so this GPIO.h will contain the drivers which are being used to control the GPIO which are present on the hardware. So these drivers are used to take inputs from the switches, and these drivers are used to give the data, to give the input or output data to the LEDs. So int main, we have XGPIO, we have two different variable, LED and dip. Dip mean switches, LED mean LED of data type XGPIO. If you will move the bar on the XGPIO, you will see XGPIO driver instant data the user. So you will see that it is a step type. If you are well known with the structure which are being used in C code, then you can understand by controlling, press the button control, you will see like that. Click on just one time and okay, you will go to the XGPIO. Everything is explained here, so there's no need to go in detail. It is implemented. So go back to the code. So just suppose that we have two variable of data type XGPIO. Every time if you are connecting a GPIO, so you need to use xgpio.h, and if you are going to take inputs from xgpio or to give output to the GPIO, you have to use a variable of type xgpio. Okay, next is simple. I created a deep switch of type int xprintf. I think this one is very simple. Okay, next step is you first of all we have to initialize GPIO. We have two GPIO, so we have to initialize them. But how we can initialize it? If you will go into the here xgpio, in that go down. Sorry, don't have anything here. Okay, just close it. Close this one. Okay. The question is that how I can understand, how I can find these functions. So just click it, control, and click one time on it. You can see here that xgpio initialize, it contains two terms. xgpio pointer, we have a pointer of type xgpio, and this pointer also have device id. So what does device id mean? Device id mean that for example, we have two different GPIO. It means that we have two different device ID. So it will take device ID and return in the value into the instance PTR. If the device exists, it will initialize the system correctly and return true. If it is so if this function is unable to recognize that ID, it will return false. So how we can find device ID? Go back to the system. This point is very important. Go to the X parameters. No. Here, Control F, write GPIO. Okay. If you will see here, definitions for driver GPIO, as I have mentioned earlier, that if you want to take data from GPIO or you want to send data to the GPIO, you need some driver. So here are the driver which will be used, which we will use now after some time. Driver GPIO, if you will see here, so it is written GPIO 0. So GPIO 0 was connected with switches, and at the same time you have GPIO 1, and this one is connected with LED. So if you will see here, you have device ID AXI GPIO 0 device ID. Just copy it and paste here. I have pasted already, and I give a pointer of data type xGPIO. So I have done this one. If this device exists, it will return a true value and our system will work. So the next step is that set direction. In the same way, if you will click here, you will go to the function set data direction. It has three arguments. again the pointer of X GPIO data type, unsigned channel, and 32-bit data. So this channel mean GPIO has two channel, but we are using just one channel, so we will write here 1. If you are using two channel, you can write here 2. So direction mask, it's mean setting the direction of GPIO. Either you are using it as input or you are using it as output. If you are using it as input, put 1111 to all 32-bit data. If you are using as input, put all 0, 32-bit 0 to set that GPIO as output. Go back to the hello world. As dip is declared as input because we are taking data from what? From GPIO. And this one as output because we are sending data to the LEDs. Okay, go back to this one. We will discuss this one later on. Here pointer, next is channel, because we are using just one channel, so I wrote 1, and this one representing the direction. It's mean FFFF means 11111 32 1. So it is selected as input. In the same way, initialize your LED pointer device ID. If you will see here, it is written 1. If you will go to the X parameter, I copied that line. Here is 1. Go back. In the same way, set direction. Channel, of course, here again I am using just one channel. Here I set the direction as output. No, go back to go down to the while. Here dp check, this one X GPIO discrete read. That function is used to read the data from from GPIO, and that function X GPIO discrete write, it is used to write data on the GPIO. If you will move the arrow on it, you will see it has two arguments, again pointer of data type XGPIO and unsigned channel. So we have just one channel. Data will come to the dip of data type XGPIO, and this data will be saved into dip check of data type int, and this data I have given to the discrete write to the LED. Okay, this data will go to the LED, and LED will go to the hardware LED. And I have shown just to verify my system is working or not to the below here. Okay, let's check the system program again. Right click here, run, launch on the hardware. Yes. Okay. Oh, it's creating some problem. Okay, reset the system. Again, program it. Launch on. Okay, it's done. Click here, connect. enlarge it. If you will see, there is no input. If I will press, no, I am on the board. If I press first switch, you can see 1. It's mean I'm receiving data successfully. At the same time, if I will press second one, if I will press third one, if I will press fourth one, for the fourth all of the 4 switches are pressed, so you can see F, and LEDs are also blinking here, but I am unable to show you. Believe me, it's working. Okay, so we have done with the system. Thank you very much. If you have any question, please post it, and if you find that video useful, please subscribe me. Thank you very much. Okay, have a good day.